Here we have a calculus problem, that is we have to integrate the function x squared times e to the power of x cube. Okay, so in this problem we have to use the method of substitution to integrate. So as soon as I see the problem, how can I decide that I have to use method of substitution in this integration? Because when I consider the particular part of the function, that is x cube, so what is its derivative? Its derivative is 3x squared. So almost its derivative is over here. The constant 3 is missing. It's not an issue. Anyway, so the derivative of this x cube is almost over here. So whenever the derivative of a part of a function is in the function itself, then we can use method of substitution to integrate such function. Okay, so before that, what we have to do is we have to write the derivative together with dx. Let me write over here. Then I'm getting e to the power of x cube times x square dx. Okay, now so for which part do I have derivative? I have derivative for this x cube. So for that particular part, I have to assign a new variable. So let me assign a new variable u for this x cube. Let me write it over here. Let u is equal to x cube. Okay, now I'm going to change the complete integration to the new variable u. So here we have the original problem in the variable x. So we integrate with respect to the variable x. That's why we write dx over here. When I change the complete integration to the new variable u, so instead of dx, I must have du. So here I have u. If I want to get du, what should I do? I have to find derivative. And also here u is the function of x. So if I want to get du, I have to find derivative on both sides of this equation with respect to x. If I find derivative of this u with respect to x, I'm getting du over dx. So what do I get if I find derivative of this x cube with respect to x? So I'm getting 3x squared. Okay, now my aim is to get du. So I have to get this dx in denominator. For that, I multiply both sides by dx. So when I do so, I'm getting, this dx will cancel out. I'm getting du is equal to 3x squared times dx. Okay, so here, when I look at the stuff over here and here we have just x squared dx, but here we have 3x squared dx. So I don't want this 3 over here. So for that, what should I do? I have to divide both sides by 3. So when I divide both sides by 3, this 3 will cancel out. And this du over 3 can be written as 1 over 3 times du. On the right side, we have x squared times dx. Okay, now let me go back to the original integration. So here, integral. So this x cube can be replaced by u because I assigned a new variable u for this x cube. Then it will become e to the power of u times, for this x square times dx, I can plug in 1 over 3 times du. Because this is stuff equal to x square times dx, then I'm getting 1 over 3 times du. Okay, so when I integrate, when in a function, whenever the variable part is multiplied by some constant, the constant can be moved out of the integral. Then this constant 1 over 3 can be moved out of the integral. Then I'm getting 1 over 3 times e to the power of u times du. 1 over 3 times. So we know that the integration of e to the power of u with respect to u, what is it? It's just e to the power of u, positive integral constant c. So we add integral constant c because it's an indefinite integral. Indefinite means we don't have lower limit and upper limit. If you have lower limit and upper limit for an integration, it's called definite integral. When you evaluate definite integral, you don't have to add the integral constant c. But when you evaluate indefinite integral, I mean the integral without limits, so we must add the integral constant c. And here we have u. U is a variable taken by us. It has to be replaced by the original stuff, that is x cube. So because u and x cube are equal, so we can plug in this x cube for this u. Then I'm getting 1 over 3 times e to the power of x cube positive c. So the integration of the function x squared times e to the power of x cube is equal to 1 over 3 times e to the power of x cube positive c.